we have seen that integration can mean finding the area between the curve and the x-axis on a function. That's more particularly used when we have definite integrals, when we know where we want to stop and start on the x-axis on a given function. But when it comes to integration with indefinite integrals, we know this is basically taking the antiderivative. There are many methods for taking integration. The most basic, easiest one is what I would call by the brain. These are easy enough to think about and just think backwards. For example, you might ask yourself, which function has a derivative of cosine? And that would give you the antiderivative. Sometimes we think of, when it's a polynomial, we would add 1 to this power and divide by that number. So we would get 1/6 x to the 6th, plus c, of course. All indefinite integrals have that plus c for that constant that could be there. So these are the easier ones. We can think backwards. But we know they get a little trickier. So another method for integration is called substitution. A few of these easier substitution ones you might think about doing in your brain. Some of them we can see, especially as we practice more. But for substitution, the main key feature of this method is you're picking a u value, or a u function. The best way to think of picking this u is by looking for a function that if you took the derivative, that derivative, or that du, would also be present. In these examples below, say under this radical here, we have x cubed plus 2. If that were my u, when I derive it, I get 3x squared. We can also see that, except for the 3 part, which constants are easy to handle, or easy enough to handle, our x squared is present. So the function of u and its du are both present. That's when we'll use our substitution method. Some tips for picking the u are denominators, radicands, those are things under the radical, parentheses, any trig angles, or perhaps an exponent with a function, say like e to the 3x. The third method that we have comes when we have a couple functions that we need to antiderive. It would almost look like we're going to have to do what we used to think of as the product rule. You have two functions and the derivatives of each other are not present. So for example, here I have cosine of x times e to the 7x, or natural log of x times cosine of x. All of these have two separate functions and they're not the derivative of each other. That's when we would need a method that's called integration by parts. The formula for that is if you're trying to integrate a u function times the derivative of a v function, it will equal the u function times the v function minus the integral of v function times the derivative of u. Now that seems like a bunch of chaos, and a lot of examples will help you get better and better, but another thing to think about is it still matters what you pick for your u. Just like we had some hints on what to pick for the u with substitution, when it comes to integration by parts, you might wonder which of these function is the u function. Our functions are chosen in this formation with this acronym. So L is for logs or natural logs. If you have any of those are going to be your u function. I is for our inverse trig functions. We don't see them a lot, but if we do, we generally let those be the u function. P is for any polynomial, like x squared or 6x plus 2 over here would be a polynomial. E is for exponentials, and T is for trig functions. We pick our u value in our integrand out of this order, so starting with logs all the way down to trig functions. There are even more methods of integration, but for now, we'll just start with these three.